Hey people, welcome to Drop Minted, where electronics is made easy and simple. So in this video, I'm going to tell you about why RTL engineers must have physical design knowledge. So every RTL logic is built using a knowledge of physical design. So if you're aiming for an VLSI industry, you should have the physical design knowledge, even if you aim for RTL design engineer. So I'm going to break down why this knowledge is important and how can you gain it, like in which scale you have to learn the physical design. So first, let me show you the agenda. So let's just start with the why physical design is important for RTL engineer, like how RTL affects the physical chip. So let me show you a small code. So I have took it as an example. So this is a code where this code is written by the engineer who has no knowledge of physical design. So this code is written by someone who has no physical design knowledge. So this is some code to add the multiple inputs A, B, C, D, but in the step-by-step manner for each and every clock. So if someone writes this code and it is logically correct, so you can say it as A plus B will be added to C, and that will be added to the D, and that will be added to A and F, and following by G, H. So what's wrong with it? The logic is completely correct, but you know what happens if you synthesize it? So this block of code will be generated as a giant combinational chain of block. So once you synthesize this, the design will be like, for a single cycle there will be a huge combination block executing all this in a single cycle, putting more adders into a one design. So it will be chaos. I cannot even imagine that. So that level destruction will be happening in the synthesis level. If someone with a physical design knowledge carries out this logic, it will be like this. This code is written by someone who has the knowledge of physical design. So what he did is nothing but a sequential design. So he has used non-blocking statements to make sure all these additions are carried out in a single cycle by different adders. So this will prevent the physical design synthesis to take out all the blocks. Each and every one will be executed simultaneously at the same clock, and this entire thing will be added into the value y. So what will be the difference? So if you still don't get the difference, let me show you something. So imagine it is like an flip-flop here. It's a flip-flop. So we can imagine it as a flip-flop here. So flip-flop. And there will be another flip-flop. So you have to perform this addition operation we have shown here, like this one, the entire thing. The Y output should be get A here. So we need the Y output here. So we need Y here. So the input will be sent here. So we need to perform the all addition inside this space. So we have to perform all the addition here, and we should provide the output here. So what in the first case will be happening? So in this case, the operation will be like, there'll be a couple of adders. Like, let's take the adder as triangles, for example, not a physical design diagram. So let's say this will be an adder, and in the first design, the design will be something like this. Like the input will be going through this all the way from the first triangle, second one, third one, fourth one, and it will go like, it'll jump through all the adders one by one and get back to the next flip-flop. This will all happen in a single cycle. So imagine all this happening in a single cycle. That will hugely destroys the static timing analysis, and it causes a lot of violation in it. So what we do is, the engineer with physical design knowledge will build something like this. In this case, what will happen is, let's take the same example, and here. What happens here is, there will be same adders, but they will be running sequentially. Like there will be adders like this. Wait, let me take only 4 for the example. There will be like the same amount of adders like in the sequential case. So the input will be like coming to all of these, so one by one, and all the adders here will be added together to provide the input, like this. The output will be given to the Y. So this is how the physical design knowledge engineer will design something. So this is a basic example, and there's a lot more to understand in the physical design. So if you want to know about something, the VLSI design flow is like this. So let me go to the edit again. So next, the design flow and how the chips are actually made. So this is the design flow you have actually seen one, actually, if you are aiming for an VLSI industry. So first, the specification will be designed and all the RTL flow will be carried out, and then the physical design will be carried out. In the physical design only, the entire design of the chip is completely designed, like the physical chip is designed. So based on the RTL, the logic, the physical chip will be designed. So you have to get the knowledge of this physical design flow, like how the logic is converted into an actual transistor level physical hardware. So only then you can build an actual efficient logical RTL. You have to imagine everything before you write your logical code. So that's why physical design knowledge is more important than anything. So next, the flow will be like this, and the transistors will be aligned based on the logics you are actually building. So physical design knowledge is must to have. So next, what tools is used to convert a chip from an logic to an actual hardware? So if you have already knowledge in the VLSI field, you know what tools have been using now, like Synopsys, Cadence, or anything like that. So, but you can also try it on your own for like your learning purpose or something. You can go with the open source tools like OpenRoad and OpenSTA. There are a couple of tools available in the open source field. So you can just go download it from the GitHub. You can use it on your own terminal or something. So that's it. So everything is available. You can just go learn by yourself and design your own chip completely from RTL to the GDS. So next, the final thing is, I just want to ask that physical design is more important, right? So I'm planning to do some physical design tutorials in this channel. So if you are interested, you can just tell me in the comment sections, or I'll be just posting something I learn about it, something interesting or anything that may be useful for you guys. So thank you. If you find this video useful, drop a like and comment down. That will be so helpful for me to make more content such as this. If you are into VLSI and electronics, subscribe. And if you want to learn more about such kind of topics, follow me on Medium to read about it. We are also building a Reddit community to share weekly updates too. All the links are in the description. Thank you.